And I'll take the last one. They already got me on.
And there's water? Look at, you guys gave us water and everything. Everybody went to the airport already.
Yes, but they can hear you.
So we're going to have some fun today.
Okay.
Ladies and gentlemen, we're going to get it to start now. This is the last session of the event, so we're going to have some fun. We're going to take it easy. You've already seen the panel description, so I'm not going to bother reading it. We have 4 great panelists to talk about intelligent infrastructure. We're only going to talk about security, but not in front of you because it's secret. Okay, I give up. That's the last joke. From now on, it's going to be the real thing. I've asked each of the panelists to give a 5-minute overview of who he or she is, what the company is, and then tell a story. Tell me something about adopting technology or adopting or disadopting technology, something like that. And then we're going to go with Q&A. I have to warn you, I have questions here. If you don't want these questions, you have to ask your own. So this is your chance to ask whatever you like. This is your chance to get involved. This is your chance to be known, to be seen. No, that's probably not enough for any of you. We're going to go left to right. Please, why don't we shoot? Go ahead.
Hi.
They all want to hear about trucks.
Yeah, yes, everyone does, right? My name's Deedy. I work with Volvo Trucks North America. For those that are in this area, we're proudly located in Greensboro, North Carolina. Just up the road here, about 1 hour. In the North American headquarters. We build all of our trucks here in North America. Our largest plant in the Volvo Group's in Dublin, Virginia. We build our engines and transmissions in Hagerstown, Maryland. And we have approximately 160,000 trucks that are connected, reporting data every day here in North America. So that's Canada, US, Mexico. And my role and my team's role is to make sure that we can leverage that capability to help provide our customers the success that they want to get out of their Volvo product and make sure they get the experience and the best that we can offer. So there's been a huge sea change in how we look at the trucking industry over the last 20 years since I started with Volvo Group. And one of the key things has been leveraging that connectivity to really change the way that our customers are able to understand how their trucks are performing, the job that they're doing, and get the most out of them. So one of the things that really changed within Volvo here in Greensboro happened about 2012, where before we had connectivity as an option, something that customers would buy and maybe track their trucks where the location was. We made a decision to say that at Volvo Trucks, we're going to use this and leverage this and put it in all the trucks because this is the way we want to do business. We feel that this is the way that by helping monitor how our trucks are performing and trying to get ahead of issues that our customers may be experiencing is the key thing to help them in our industry become successful. And one of the first, so in 2012, we started monitoring trucks and contacting customers. If you've ever been in a car and you see the yellow light pop on your dashboard, that's not a good experience as a driver of a car. And we had one customer that they were driving a truckload of chickens in Arizona in August. Imagine that thought at about 100 degrees out, and the light pops on, and you say, oh my God, am I going to make it to where I need to go to deliver these chicklets to where they need to go? And one of the customers, we were able to contact the customer that owned the truck and that driver and let them know that we see that there's an issue on your truck, but it's not a serious issue, and it's something that can be taken care of next time the truck is back at its home base in about a week. And really, it was pretty amazing. The feedback from the customer was, that's the type of customer, that's the type of company we want to do business with. And so with our connectivity platform since we continue to develop opportunities to help become more proactive in supporting our customers when there's an issue and even when there's not an issue, to help them get the success that they want to get out of their product.
So the truck balked.
The truck balked. It didn't balk. It's really,
That was supposed to be funny.
when there's a yellow light, you don't know if it's serious or not, right? And really, helping them make a good decision was the key thing we learned in that one experience that's really helped drive us to, we want to be able to provide our customers actionable information in real time to help their business. And that's really where we've taken the industry today, and pretty excited about where we're going.
Good story. Thank you. Rajiv.
Thank you, Richard. Well, Connell, your introduction is just a great segue to what I was going to say. So let me just quickly tell you a little bit about where I'm from. I'm in Silicon Valley, Bay Area. Work for a company called RTI that you may have never heard about.
This morning.
This morning?
Yeah.
Anybody was here? So you probably know everything about it. And really, I'll just, in a nutshell, we are providing a connectivity framework. You talked about connectivity, and I'm a solutions architect, a systems architect, so I'm going to tell you about how to build these type of systems and how you actually put these things together. Now, one of the big sort of things you've also been hearing about is autonomous driving, self-driving cars. And it's not just cars, it's trucks, and it actually goes beyond trucks. It goes to intelligent, self-driving rails. Well, not driving, but autonomous rail. So you can take the word autonomous and really apply it to various modes of transportation, and that's really the intelligent transport infrastructure that we're building. And so, how do you go about building those systems? Because they have some very unique requirements. And that's really the kind of stuff we do as well. There are systems where the volume, variety, and velocity of data is huge. And it's continuing to grow because you're starting to put more compute, and you're starting to have many sources, and you cannot all put it all in the same place. So you need to distribute it, and that's distributed computing. But then how do you get the right data to the right place at the right time? And furthermore, these are systems where if the right data doesn't get to the right place at the right time, and the right answer gets there too late, then it's the wrong answer. You might end up doing the wrong thing and making the wrong decision and get the wrong outcome. So data timeliness is extremely critical. And that's really what our company, we are good at, and that's what our technology also provides. And we've been working with systems in autonomous vehicles, all kinds, and also in the back end, the connectivity infrastructure to the back end. And so that's a little bit of the background. What I wanted to share a story with you, and this is really coming from a few observations that I've been making in the field. So you've all heard of the IIC. How many of you have heard of the IICF, the Industrial Internet Connectivity Framework? Some of you have heard of it. Okay, I see a few hands. Right, so I chair the connectivity task group at the IIC, and been the lead author and led the development of the connectivity framework. It's a document available now for 2 years. We did a small update last year. You can go to the IIC webpage and download the documents along with others. But one of the things we did is we looked at connectivity for industrial IoT and across different sectors, because as the IIC, we are trying to drive transformational business and societal outcomes. And for that, you need the next-gen infrastructure. Earlier today, I think in the audience, in the previous panel, somebody said, TCP/IP is the standard that led to the success of the internet of people. But then when you start taking people out of the system and you start doing autonomy, where machines are making decisions, then, what is that interoperability standard? So this is where, at the IIC and the IICF, we established sort of the next, what are the new minimum requirements of the connectivity standards, and we established this notion of syntactic interoperability as sort of the minimum baseline, because that's what you need. And that's really about structured data exchange, right? So that, machines can unambiguously understand the data that is, and there's no human in the loop, right? But what I wanted to share with you is that that's sort of the starting point, but there's more to it. And the style of system architecture also matters. The philosophy of system architecture, the paradigm you apply to building these systems also matters. And different approaches lead to different outcomes. So one of the things that we find successful in building these type of systems is the idea of decoupling the data from applications and treating data, and we've heard a lot about data earlier today, but treating data as a first-class citizen in the architecture. And really putting that at the center, and we like to sometimes call this data-oriented architecture or data-centric architecture. And this is an approach that's been widely successful in building IT applications with databases, and that concept here becomes a data bus. So that's something we are finding very, good success with. But it's a new approach. It's a new way of thinking about system architecture. And really, the philosophy of system architecture matters. And so the story I wanted to tell you was about a U.S. Army tracking system that we helped with. And it's sort of a very nice example because they had spent about 8 years building a system with about 500,000 lines of code, running on 21 servers, and they're tracking assets, and it's about 20,000 updates a second. And the story I heard was they had to reboot servers every 8 hours because they would just run out of memory. Now, those of you in the IT space, this is probably not too far from the truth. People do that all the time. But you cannot really do that in operational systems that need to run 24/7, right? And remember the time criticalness part I talked about earlier? So how do you build those systems? So we started a project with them just to sort of prove out a new paradigm of architecture. And what we did was we worked with them for about a year, and about 50,000 lines of code, it's about a tenth of the code, and with just one laptop, and they were getting about 250 plus updates a second, a number of objects and tracks, things they can track. So it's like more than 10 times improvement. And really, fundamentally, it was the technology stack, but it was not just the technology stack and not just the idea of syntactic interoperability, but applied, that technology, that stack applied right. So really, the point I wanted to get across was the approach, the philosophy of system architecture also matters, and it matters hugely. And doing it the right way, and I think we have to sort of advance the state of art in the way people apply. These are known techniques, but not widely known. So that's really what I wanted to share with you. So,
Deedy, a view from our host, SAS Institute.
Sure. Hi, everybody. My name is Katie Salamati. I'm the transportation subject matter expert for our government business unit at SAS. And that means I work with the federal, state, and local transportation agencies to identify what their data analytics needs are. I'm also adjunct faculty of civil engineering at North Carolina State University. So I teach intelligent transportation systems and sensor and instrumentation. And I really wanted to emphasize on the impact that the government, especially the state government and local government have on, as a roadway owner and infrastructure, on any of these intelligent transportation system technologies, whether it's going to be connected autonomous vehicles or any of the other technologies. They are the owner of the roadways, and they are the ultimate regulators. So it's very much important to get them involved in all these connected autonomous vehicle pilot projects that are going around. And also, they've also become very active in making sure that the infrastructure is very smart and very resilient. So a success story that I wanted to share with you is around the work that SAS has done with one of the European countries, the Dutch Ministry of Netherlands, Rijkswaterstaat, which is a very successful story even for the US federal government, that they are trying to model after the resilient infrastructure. And what SAS has done is that we are using true analytics and true analytics on the edge, where we are analyzing over 15,000 sensor data that are located in the dikes, dams, roadways, bridges in real time, monitoring that, understanding what the patterns are. And if you know about Netherlands, they are almost at the sea level, below the sea level, so they're very prone to flooding. And any of the water coming from the ocean. And so the analytics that we've done, they actually have some gates that they need to close in order to protect the city and protect the country from flooding. And before the SAS implementation, they had to close this over a 2-year period, they had to close the gates for over 200 times, every time causing them about 3 million euros, costing them that much. Once we implemented the sensors and we started doing analytics on the edge with the sensors and in real time monitoring what the status of these sensors are that are located in the dikes and dams and roadways, we were able to bring that down into 6 times over the same amount of time period, which is huge cost savings for them. And also, it also helps them to be more proactive and more predictive toward what the environment is going to be and provide a very resilient environment, so then they are alert about any of the harms or risks that are happening at the roadways or at their infrastructure. So we are very proud and we are very grateful for that opportunity to be able to help them and get involved in really having a more resilient infrastructure and help eventually with the citizen well-being.
I love a panel that starts with a damn story. Last but not least, Christopher.
Thank you. Good afternoon. Thanks for sticking with us. You know, not everybody went to the airport this afternoon. So I'm Chris Miyagi. I work at NetApp as the Director of Global Automotive and Autonomous Transportation. And if you're familiar with us at all, you know, we're a data management company, and we help you move your data from edge to core to cloud, so into commercial. We, as I talk to my colleagues, I haven't saved any chickens lately. I apologize for that. But we, as we talk about this topic and really around trying to develop connected vehicles or autonomous vehicles, I look at that data flow in 2 really different characteristic sets, right? The one where we're looking at dashboard lights or my tire pressure is down and those kinds of things, that's one. Very little bits of data being transmitted maybe over the air across millions of vehicles. That's the use case trouble that in 20 years from now, whenever we have autonomous vehicles and millions of them driving on the road, that's the one that's going to threat to break the internet, everybody keeps saying, I guess. The one that we really have been focusing on with our customers is in the research and development, the development of the neural network and the algorithms to create a self-driving vehicle. And that's the sexy part, I think, for me personally as a car guy, and that we've been working with. So we've got customers going anywhere from, on average, 25 to now well over 100 terabytes of data per test vehicle per day. If you've got 100 vehicles that you're running around, if you're one of the larger car companies, even if it's 10, we're starting to get into a problem. If it have to be a company that manages data and sells storage equipment, this is a good thing, right? We're seeing 100 to 500 petabyte environments. People are talking about exabyte environments, which is, I never used that word a couple of years ago, but now it's starting to come back around. So the ability then, you know, we talked about autonomous and being able to get that data to the right person, right time. The challenge in this environment is that the typical data scientist that's trying to develop that algorithm to drive a vehicle is doing a 50 petabyte data download so he can run their model. And there's 10 of us at the company. And then when we partner with companies like NVIDIA and others like that, the challenge really is then to feed that beast, to be able to give enough data and enough volume to all those GPUs so you can actually get some results out. So we're working on that quite successfully, and then moving some of that data off the vehicle itself and into the environment. So it's tough to move 50 petabytes or 50 terabytes of data from a car that's driving around Raleigh or Detroit or Silicon Valley into your data lake and into your environment. But we're doing that very successfully, and we continue to look at our product suite. I'd like to give an example of one of our customers and why this is a challenge. So from my point of view, I'm not a data scientist. I'm just an engineer that learned a little bit about data science. And I think that our deep learning and our machine learning models will never quite get to full AI until we start incorporating human behavior into those models. Until we can tell the machine how I would react also, we're not going to be able to get the car to do the same thing that I would do. That's how we end up with accidents in Silicon Valley and Arizona, because the machine didn't act like the person would do. And I got a great example of one of our automotive customers. They took one of their test vehicles out with engineers on board, and they're driving around, it happened to be Detroit. and in the summertime, went out, did a great test. They went out for all afternoon. The vehicle did what they wanted to do. They collected lots of data, went back to the barn, high fives all around, downloaded it, and then they let the data science noodle with the model a little bit, which is probably the problem. Then they went back out in November. Same vehicle, same test. What do you think happened? Complete failure. It barely made it down the street. Right? And this company is in a suburb of Detroit, not downtown. So they're a little bit outside of the city. So I said, well, what happened? So they go back, they take a look at the model again, they take a look at it, they look at the code, and the machine learning model said in the summertime, well, if I'm on the road and the trees are over there and the trees have leaves, it made an association to the leaves on the trees and said, if I'm not by leaves, it's good. Somehow it made that relationship all by itself, which is terrific. It succeeded in learning. Except in November in Detroit, there are no leaves, right? There's snow on the ground now. So now it sees snow, it sees bare trees, and has no idea what to do. So those are some of the challenges I think that we're going to continue to face, and why some of us think that we're not going to get to that level 5 fully autonomous level for 2030 and well beyond that until we get some of those behaviors added back in.
I really like any panel also that talks about PETA bites, because I thought PETA stood for people for eating tasty animals. So I've got some questions here. I'm going to start with a question just to get the panel going, but because of trips to the airport, we've reduced the number of people enough that you can get your question in. It doesn't have to be exactly the topic that we've got here. Raise your hand and somebody will bring you a mic, hopefully. I think Cheryl will bring you a mic. She's getting one now. So in the meantime, let me get us started. So I want to ask a silo question for Volvo. Silo question, yes. I know it sounds like agriculture, but it's not.
Or farm questions.
It's not a farm question. So I also know somebody who works for Volvo, used to work for Volvo Construction Vehicles based in Belgium. And he also talks about all the data that they collect from the construction vehicles. How much integration is there with that data and the data that you're collecting, vehicle location data and health data and so forth, from your trucks all over the world?
Well, there's some parts of information that make sense that integrate, but mostly they have a much different application, different components and other things that for construction equipment, we don't share that. We more share best practices on what we do with the data and how we process it. So one of the key things that we talk about with Volvo construction equipment is, what is the duty cycle? Sometimes it's the same engine that's in a truck that's in a wheel loader, but what the parameters should be set at, the setting of the vehicle and everything are quite different. So we talk more about best practices on the last mile. And in trucking, last mile is making sure that delivery gets to where it needs to go. But with our services, if we're trying to talk with customers and trying to get the information to them, again, to make good decisions and be convinced that this is good information, all the data science in the background, and we do a lot. We work with SAS. We have a lot of information we process. We've taken the approach that it's really mostly a human or an email that's going to the final person to help explain, this is what you're seeing, this is what we're seeing, and this is why we're recommending this. And we found that that's been one of the key success criteria for us, and what our customers give us feedback and say, that's the way we want it delivered. We just don't want a bunch of data dumps saying you should be doing this. And
duck that question, Will. Okay, well, that brings up the data management question. Everybody talked about data management. What are some best practices that we can bring home about data management? Anyone who, maybe Katie, you want to try that?
Yes, absolutely. So when it comes to the intelligent transportation systems, unfortunately, the area that is really lacking is data management. And everybody's realized that. They've started realizing, because we have as I mentioned, we have the pilot projects going on connected autonomous vehicles, on smart infrastructure. And it's all about making the hardware work, making the communication work, getting some data and see, what data is telling us. But really the concept of the data management is about integrating the whole various different sources of data together, and then driving insights from that, and then getting into more of an advanced analytics, which I call everything, when we get to the area of advanced analytics, it's really predictions and being able to predict in using machine learning, using forecasting algorithms, using all of that. But before getting into that, the preparation of the data takes 80% of the time, and understanding where you can pull in the data from the right sources and make sure the quality of the data is right, make sure the metadata around that is right. It's all about the data management, which is now, I guess, more and more companies, technology companies, and even, again, going back to the roadway owner infrastructure, the DOTs, Departments of Transportation, are realizing that we're going to have so many sensor data coming in. We need to be able to bring all that data together. And that's the data management. Whether data management, it comes to, as a batch processing of collecting the data, managing it, and then looking back at it, maybe a week later or a day later, or data management in real time. When you talk about the edge analytics, you still need to see what the other sensor is seeing and what the weather is showing and what the other truck in front of me, if we are talking about truck platooning, for example, that Volvo is working on, what is it that the other truck is seeing? What is it that's happening from the information that is coming from the roadway? And that's where the data management comes in. So it could be in real time, or it could be in near real time or not real time.
So, Christopher, data analytics training going to help with that?
Well, that's spot on. But as I think about it, and we're talking about communication and the movement of data. As I talked about, there's I think in my brain, two distinct areas where this data is being used. And in a current we all drive connected cars, right? They're all connected in some way. That data is very low volume, and it's easy to.
Hopefully, they're not connected to any other cars.
Well, yeah, that doesn't exist. So they're just connected to a phone home, wherever that is. But the ability to put that data and move that data as you're trying to manage it is so much easier when you're dealing with kilobytes of data. But often, everybody here has probably been in a situation where somebody said, an ABC customer, well, we're all cloud. We're cloud only. We're cloud first. The CEO says, hey, we're cloud first. So you guys are going to put everything in the cloud. Well, in that particular case, when we're dealing with those low volumes of data, that's just fine. Mm-hmm. Maybe even when we're dealing with remote locations of facilities, moving some of that data might be okay if it's in a private cloud, right? But the data volumes I was referencing earlier, there's no way you're using the cloud for that, right? We're not going to use 5G for that. We've got a customer, I'll completely stay away from naming who it is, but they're doing all of their analytics in the cloud. And their cloud bill was hundreds of millions of dollars last year. I think if you reported back to Volvo headquarters that you're going to spend $200 million on cloud expenses, you'd be looking to go down the street to BMW or something, right? So, that's just the way these things move. So I think the management of that data to enable those analytics and the movement of it is critical depending on what your use case is and what the business is actually trying to drive.
So you're bringing up movement a lot. I know Rajiv is thinking movement. He's talking about me.
Well, I think
he's talking about movement of data into two different places. You have any ideas about how that works?
Absolutely, yeah. So, we can call it data management. Essentially, when I was talking about data being a first-class citizen, really, this is what data management is about. And you can roughly break data into data at rest, which is, the storage part, and then moving the data, right? And then building applications around data, right? So that's the data-centric, data-oriented architecture approach I was talking about. So these all are sort of, puzzle pieces. They all fit together, right? You have to be able to store the data, you have to be able to move the data, and you have to be able to build applications around data. So what's sort of the unifying piece for being able to do all of these things, and how do we advance the state of the art so that this is more seamless, so you don't have to worry about data quality, so you don't have to worry about all those things, right? So you need an agreement on sort of the foundation, which is built around data models, right? So we know how to do these things, but those things just don't exist, but data. What are really data models? They're agreements, expert agreements on what the data in that domain looks like. Right now, that can take many representations, but as a model, it describes fundamentally what the structure of the data is. If you're going to describe location, well, how many ways do you think are there to describe location? Fundamentally, the model is, well, you can have an X, Y, and maybe a Z, right? And now you have a location Well, now you can have it in centimeters or meters or inches or whatever your favorite unit system is. But fundamentally, there's semantics. So, that's a simple example, but you can start to say, okay, we can build that out, right? So how do you describe the domain of, transportation using data models? Because that gives us that foundation to be able to do all those things we were talking about, right? To store, to move, to build applications, which is really where I'm coming from. So how do you build an ecosystem where I can have, just like, the app store you have on your phone, I can bring in a new application that starts working with the data that's already available. It can discover the data that's there. It can then create new algorithms and new sort of, things that drive new revenue or new, benefits for people, users, and so on, right? So you need that data backbone, and you need that for data at rest, which is databases. You need that for data in motion, which is a data bus.
So you really talked about two things. You talked about data in motion. You talked about metadata. You know what metadata is, right? I'll tell you what it is. I never metadata I didn't like. Okay, you didn't like that one. Is that the biggest impediment to autonomous cars, Christopher?
No. I think the biggest impediment is the fact that we're talking about unstructured data versus structured data. If you break it down to make it real simple, because I think this last conversation in your head, you were thinking all structured data.
Yes.
If I'm right. Yeah?
Correct.
Yeah.
And I'm sort of making the assertion that if you're going to advance the state of the art, and where we need to be structured data when we start taking people out of the loop. We need to get there. We're not there.
Yeah.
Right. So anyways.
Yeah, I mean, structured data is a piece of cake. I mean, we can do analytics on structured data all day, just whip out R, and you can build any model that you want, right? It's because with autonomous, everything that we're dealing with, the radar, LiDAR, going from 2G to 4G to 8G to, who knows what's next, cameras, and adding more and more cameras, more and more sensors on it, every one of them collecting all these reams of data, these 100 petabytes of data or terabytes of data. I think that's the real challenge. It's the fact that we're creating a kind of data that until then we only had to deal with in social media and DreamWorks or somebody like that. That's the only place we had unstructured data before. It's social media, all those photographs and everything that we take. Now we've taken and literally created a whole new industry, excuse me, where they're trying to deal with a data that's not compressible, doesn't like to be moved. Everyone's terrified to dedupe it, right? I don't know if I just drove for 10 hours down an expressway. What do we got here? 405's in California, whatever the highway is out here. I've got 10 hours of driving around on an expressway, and I'll pick on Volvo. As Volvo data scientist and engineer, I'm terrified to delete any of that because I don't know what the model needs to see.
But is it petabytes of data? I mean, you're collecting real data from real trucks today. How much data are you collecting?
No, not at that volume for what we're trying to do today. When you go into the realm of autonomous and other things, then you're talking about a whole different level of data. I think one of the first autonomous trucks, Octo, had a truck, it was about 2 years ago, and it made its first delivery, and it was for Budweiser.
Yeah.
Shout out to the beer drinkers in the world. But
that would be all of you, we know.
But if you looked they didn't show that. They showed the nice picture of the front of the truck and it delivering the beer. If you opened up the cab, there was basically a server farm in that truck. And, who knows how hot it was in there for that driver. But that was sitting there, not driving, just, hydrating. But, that's, we have a ways to go. The amount of data to do that sort of thing, we have to take it in increments. And just the amount of data that we're getting on fault codes, as you mentioned, I think we're getting 1.5 million fault codes or information pieces, many more than that, but on just the fault and the condition of the truck per day that we're processing through our SaaS platform to bring insight to our 175,000 trucks.
For those of you who didn't know, beer is not a hydrator. So, we have questions out here? It's all obvious?
Well, before we get to the question, I wanted to add one thing about the unstructured data.
Okay,
Sorry, I'm glad that you brought that
we'll
up.
This gentleman got the mic.
Mainly because, especially when we're talking about the connectivity, well, we have the autonomous vehicle, it's one thing, and to some level, we can't have fully autonomous if we don't have connectivity. When we are talking about the connectivity and connectivity to the infrastructure, then that concept of the unstructured data comes in very much, because you have the unstructured data, as you mentioned. I mean, the first thing you would think are the images and the social media and all of that, but then you also have the roadway condition, which they are not really structured. I mean, we are working with a customer who wants to predict how the roadway condition is going to be, whether it's, what is the snow coverage. And it's very fuzzy. It's, partially covered, fully covered, not covered at all. And it's all unstructured data, and it's all images that are captured from the snow plows. And we are trying to help them predict how they can see what the roadway is going to be in the next 2 hours, and in terms of the weather condition, in terms of the snow coverage. So that concept of the unstructured data comes into place, especially when we're bringing in, because the vehicles are, the telematics data, and mostly they're zeros and ones and numbers and very structured. But again, the roadway comes in. You want to take into account the condition of the pothole. You want to take into account how much water is there. Is it very deep? Is it not deep? And all of that brings in the concept of or pays more attention into unstructured data.
Good point. Sir?
Yeah, I want to talk about, we talked so much today about the disruption related to technology, but the human disruption from all of this is, to me, at the real centerpiece. You all are wanting to introduce new ideas, new products, new services into companies, and, other than the front part of that bell curve, they're not interested in any of your innovations. So are you all working at all on the human element in terms of how do you achieve greater agility within the culture of these companies that you're focused on delivering your value to?
Now, we had a story on exactly that from Volvo. I'd like to point out he already answered your questions. Anybody else want to take that, Reggie?
Sure. I'll take a crack at it. Anybody use Uber, Lyft? Let's see. All right. So you're already sort of shifting to the right on that bell curve, right? So, because now you're not thinking about driving, right? I was thinking about taking a Lyft to the airport. And then Christopher said he had a car. Wonderful. But I don't rent cars anymore.
It'll still cost you.
Happy to pay.
5-star rating.
He's an Uber driver.
You got to get a 5-star rating.
Yeah. What denomination?
Yeah, come with me. Sure. That'll be $15.30.
Right. That's already a shift, right? And absolutely, you're right that there's a social change and a social sort of, technology doesn't sort of, become effective or useful until people adopt it. But now you're not thinking about driving a car. I'm not thinking about renting a car when I come to these type of events. What's the next thing? If I have to go to work and I know that I leave at 8 in the morning and a vehicle is there to pick me up, hey, I'm happy not to drive. Maybe I'll check my email and catch up on other stuff, or just socialize with the other folks.
With the car. Yeah,
right.
You're a weird guy.
Right. So now my mindset is already changing. And wouldn't you like that as well? Right? Does anybody like rush hour traffic?
Referring back to this morning, we're talking about kids who just don't have driver's licenses. I mean,
Yeah.
My kids are 30 and 28, and they don't have driver's licenses. They don't have cars. They live in the city. They take public transportation. If they need to go further, they take Uber. Mm-hmm. So that is happening, right? The society is changing based on technology. Mm-hmm. But we're talking about industrial applications.
So the next thing, this is, now do you care if the driver is a human driver or the car drives by itself? At some point you don't care, right? If somebody
Just
gives
make sure
you the
there's no
assurance,
women with bicycles in front of it.
right? Yeah.
Not funny.
At some point, if somebody's willing to give you the assurance that, hey, you're going to be safe, then do you care, right? Do you care if the metro you took was autonomous or not? Do you see the driver all the time? Do you know that many of the aircraft are already running on autopilot? Do you care? So, we are heading that way, right? So this is coming one day at a time. Like whenever I go on a Lyft or Uber, I remind the drivers, guys, you have a great job. Great that you're happy. But remember, this is going away. I don't know when, in 5 years, 10 years, but that's where technology is going. Now, that has another impact, right?
So
you put your lives in the
dark
hands of the
side
guy who
of
just said he's
this
going to
thing.
lose
You know
his
how to have
job.
conversations with drivers.
But
Do you at least tip? I mean, come on.
See your rating.
this change is coming. Right? So So we're talking about technology here and how to build these kinds of systems, and build them in a way that are safe, and that allow us to build those assurances, in a way that the systems are reliable, they're resilient, they're secure, right? And they do what they need to do. So
I see Christopher really wants to get in here.
Yeah, maybe add on to your question. It's the social acceptance of the change, though. Whether it's self-driving lawnmower, tractor, plane, ship, the ferries in Holland or someplace are starting to be autonomous and things like that. I just looked at recently. I looked at a study from McKinsey, and they did a global analysis on technology, social acceptance. Why do I want it? There was about eight questions, and they asked people all over the world. Every region of the world was different in its acceptance of what if they think this is what I want. And I also think it's generational dependent. You're going to pry my car out of my cold, dead hands, kind of from me, right? But like you said, the generation that's growing up now may never own a car, right? They'll if they're especially in an urban environment. We had one of our CIO of one of our traditional big threes in Detroit. Her son lives in Manhattan. She could give him any car she wants.
Any GM car she wants.
It's the other one. Any Ford she wants, right? He's going to give him a GT, Mustang, whatever. He doesn't want it because he lives in Manhattan and he has to deal with all that kind of thing. So it's the social acceptance I think is going to take, if everyone assumes everyone's going to accept it socially, they're very wrong.
So I think the quick answer to your question is we are seeing major social changes and we're not really prepared for them.
Yeah.
Which I suspect is the reason why you're asking the question. There's another question right in the middle here. It's a race. Who gets there first?
There's a fellow in the middle here. Yeah.
Oh, I'm sorry. You were first, and then this gentleman, and then I see a hand in the back as well.
Sorry, this is my second question today, but related to the last one, I know there's a big concern with automation, the level you guys are talking about. It's going to displace a lot of jobs. And of course, that's inevitable with any revolution. There's going to be that displacement. There's a wonderful book, Augmented, by Brett King, that tackles this topic, and everyone should read it. But I was wondering, what kinds of new industries do you guys foresee being created as a result of needing to deal with and manage these types of technologies that are going to certainly displace a lot of jobs up front, but then create long-term new and even perhaps more jobs shortly down the road?
So I've got some answers, but I suspect Katie, she's nodding her head already.
I mean, as a faculty who also deals with younger generations, I would say we're seeing more and more even the engineers that are trained in, environmental engineering or chemical engineering and all of that. They're moving more and more toward data analysis, and hence we're at SAS. So I see that being the new generations of data scientists at any level, the very sophisticated ones that could do any kind of artificial intelligence, machine learning algorithms, to all the way down to just doing simple business intelligence and reporting and all of that. It's just the data is becoming so much, data and data analysts becoming so much involved in our lives from every level. You have the, the dealerships that require data scientists because they want to understand their customer behavior. They want to understand, what their inventory is going to be, which products or services they need to promote. You have it in the marketing. You have it in healthcare. So that generation of data scientists and data analysis is becoming more and more of the new generation of, I would say, like workers, I guess, but that's the way that it's going.
Totally shocking. SAS Institute
Shocking.
suggests something else.
Shocking. Yeah.
I will tell you, I got to give my personal answer, and I'll let somebody else come in too. There's another wonderful book by Eric Brynjolfsson, a professor at MIT, an economist at MIT, talking about how this revolution is different. In previous revolutions, at the end of the revolution, 20 years after the revolution started, there have been more jobs. And the reason is pretty simple, right? Productivity increases, consumer demand increases, jobs increase. But he makes an argument that this time is different. It's always different. Nobody really knows what the new jobs are going to be. I think data analysis is, I won't say obvious, but it's clear that data analysis expertise is something we're going to need. But one of the things that we're getting from the Industrial Internet Consortium's testbed programs is, what kind of talent do you need to build these systems? Nobody really knows. Some more clear pointers so that, like data analysis, but nobody really knows where that productivity is going to come from and what the new jobs are going to be. I do know that some of the jobs are going to be implementing that automation, repairing, maintaining that automation, but there will be other jobs as well. You know, at the end of the Industrial Revolution, during the Industrial Revolution, millions of jobs were lost. At the end, there were far more jobs than there had been at the beginning. They weren't just to build the new looms and maintain the new looms. They were because the productivity increase had created consumer demand, which created enormous number of new jobs. Nobody knows what they're going to be. I do know that some of those jobs have been created already. For example, in 1989, there was only one webmaster. His name was Tim. His name is still Tim. Today there are tens of millions of webmasters all over the world. So there already has been some job creation. Anybody else want that? Rajiv?
Yeah, one of the shifts, and since, earlier I was talking about, reminding the Lyft and the Uber drivers, hey, look, this is going to go away. But at the same time, and I have to maybe start saying this now next time I get in one of those, but remember, there's still a need for teleoperation, right? So, the job profile changes, right? But the need is there, right? And human and artificial intelligence augment. And really, artificial intelligence is really a progression of automation, right? If you look at it, and there'll be people who will argue this, so I don't want to really get into that too much. But now, imagine an autonomous vehicle. It will take some time before these things are perfect, and that nobody knows. And there's never perfection, not even in the human world, right? So there are corner cases. There are cases where, this vehicle knows how to drive itself, but if it's stuck in rain or in a ditch or in a pothole, then what do you do, right? So somebody has to pull this out. So all of these things have back-end interfaces to teleoperate them, so pull them out. So now you need drivers, but they are virtual drivers wearing like augmented reality and virtual reality glasses, and they have, electronic controls, and they can now navigate these things out. So that's just an example of, what's the new form of driving, right? You're still driving a vehicle, just not in the vehicle. Right? And I'm sure there are other examples like that, but this is sort of the one that...
Drone operators.
Drone operators, exactly. That's another one.
Just quickly, in our industry, I mean, someone's still got to take off the trailer. Someone's got to load the trailer off the trailer. So we talk to customers, you want autonomous trucks? Yeah, but because I want 30% of your cost as your driver, but that's your face of your company to your customer. That's loading the truck, that's taking the trailer off, all those other things. How does that happen? So then it's just a long-term play to get to in there, and it's going to be a niche play for some time.
I just read that there's a deficit of 54,000 drivers in the U.S. alone. So you all should be driving trucks.
Good job.
Sir, this right in the middle there.
On a more practical note, how do you see the liability and insurance landscape affecting or being affected by these transitions, and whether that's going to be a impediment to implementation?
The only reason I'll take that is I was at a auto convention sponsored by Daimler a year ago, and one of the sessions like this that you guys sat in on was the attorneys from Volvo, from Daimler, from
They gave straight
BMW.
answers. What happened?
To talk about the liability when something like this happens, right? Now, you referenced, there's been accidents in the paper or in the news. The last one, I think, was the driver of a certain electric vehicle from out in California that was in the HOV lane, didn't pay attention to the car. He was driving like 90 miles an hour. The car said, take over, take over. He did it. And he looked up and hit the abutment and was killed, right? Now, if he would have taken over and turned, because the white lines weren't there because it was under construction, right? So at what point is our insurance company going to allow that AI to make decisions that you and I wouldn't do? So one of the things I reference when I'm in a meeting is like, okay, I happen to be a gentleman that has a couple of little grandsons. And so if they're in the back seat of my car and I'm going to have an accident, and my choice is, save somebody walking across the street, save all three of us in the car, or just save them? Well, as a father, you'll know what decision I think I'll make, right? But what if my decision is, if I'm only going 20 miles an hour, I'll just hit the car next to me that's parked. Save everybody. Well, what's your insurance company going to say to that? No way. Just jam on the brakes and see what happens, right? Because they don't want me damaging two vehicles. The other challenge it's going to be is, here in the U.S., we manage laws by litigation. So we wait to sue somebody. And then when we have a bunch of lawsuits, we decide then that we need a law or a bill to cover it, right? In Europe and other places, they're trying to create laws around self-driving vehicles, which I don't know how you do that. It's insurmountable to try to predict what these rules should be, right? So it's the wild, wild west, I think, legally for these, and how everybody's going to adapt to it. So you start seeing the insurance companies want to put the chip in your car, in your OBD ports and track. Well, if you put this in, you'll reduce your car insurance. The way I hear that commercial, they'll increase my car insurance because I'm a lead foot, right? So,
but it's a progressive idea.
I think that's going to go both ways, and for a very long time, because, as we were saying, this technology, not only the technology, but the successful development of a vehicle, is going to be 50 years. There's going to be a lot of people that are going to get rid of their car for a very long time. Collector vehicles, trucks, all kinds of things, right? So the adoption period is going to be very long. So I think they're just going to have to take a long time and figure it out. If you're an insurance actuarial, I talked to one, and they have no idea how to figure this out.
In this country, I think the more clear answer is it's going to take precedent. It's going to take court precedents to decide what the answer is. Nobody knows what the answer is going to be beforehand. One of the first liability suits in the United States was a suit against the car dealer when the guy that's driving the car got into an accident. And there was a decision that the car dealer was not involved, even though he had sold the car. He didn't build the car, he sold the car. Anyway,
but
the answer is it's going to be precedent. I'm sorry.
I also wanted to say, so I have a different spin to this, and this is, my experience. And when I get to, in front of the legislators, this one was in Ohio, that one of the legislators hosted a session of experts, and he wanted to know, okay, what type of laws we need to have around connected autonomous vehicle? What is it that we need to think about when it comes to connected autonomous vehicle? So I see even the lawmakers are trying to be more proactive and get more insights from industry. And in that session, there was a person who was representing a group of insurance companies. And he was, one of the things that he was mostly focusing on and interested was that let it be less regulations, let the insurance companies experience and see what best works for them, and then we can figure out, okay, how we can have the insurance laws and regulations and all of that and come up with some suggestions to the legislators. So even insurance companies are realizing that this is something that they have to take on. So I wouldn't say they would look at it as an impediment. I would say they're welcoming the challenge and they're trying to understand the challenge, but they're also wanting the lawmakers, I don't know if it's good or bad, but they want the lawmakers to be less regulations, less limitations on them, so that they can figure it out themselves.
Lawmakers will just tweet some new laws. I'm sorry, that was an accident. I'm against proactive legislation. It's almost always wrong. And a great example actually is in the IoT space. The Digital Economy Commissioner of the European Commission about 2 years ago announced that they were going to be testing IoT devices. And if you didn't pass the IoT device security test, you could not sell your device in Europe. Suddenly, all the IoT devices disappeared. That's not an IoT device. There was a question back in that corner. Sir.
That's fine. Well, I guess I'll have combined. One question will be like two parts, but basically, I was looking at the data governance security, and we're looking at insurance and things like this. It kind of still goes full loop in that if you don't have assurance of the information and data going out there, you have an accident, you can have litigation where there is no proof. And I'm seeing that a lot of times that this unstructured data from these sensors and things like this, because they're not secured, it could be that the data that could be corrupted and during an accident, and therefore the insurance, and there is no, as you were mentioning, no real highly structured data governance for many programs, that this could cause a liability issue.
What is it with you people in insurance?
I have to pay it.
And we all have to pay it. Anybody want to take that?
Well, I'll take it from a technology perspective. Maybe somebody else can comment it. So, on it from a different perspective. But from the technical architecture and the technologies, the standards that are available for moving data, because that's really, I think, what you're talking about, right? There are secure standards available to secure the data at a very fine-grained level, at the level of structured data. And I was talking about structured and unstructured data, but we can think of unstructured data as one instantiation of data where there is no form to it. So it can also be captured in the same set of frameworks. Of course, structured data is much more sort of immediately useful. Unstructured data requires more work, right? So that's why we were making that distinction earlier. But in terms of moving that data around, there are security standards and very fine-grained security standards which can go from, we talk about, authentication, which means, verifying who that data is coming from. We talk about, access control, which is saying, can you read that data or can you write that data? And, very fine-grained control at the level of individual data flows and data objects in the system. We talk about data integrity, where, we make sure that data was not tampered in transit, right? So all those pieces are fundamental building blocks in the architecture, and this is obviously something we talk about every day as people who are like building these type of systems, and those technologies are there. So now you've probably also heard many people talk about devices out there are not secure, right? So the state of the art in terms of what the market has done and where it's going is evolving. Those things and the breaches you've heard about, but a company like Volvo or any of the car companies, the first thing they worry about is safety and security, right? That's
Drive safely, I think it is, yeah.
Right.
So that brings me to a very specific question.
Yes.
So you're collecting a lot of data from trucks. I see you want to get into it, don't worry.
Yeah.
You're collecting a lot of data from trucks. There's obviously a liability created, an insurance liability, and a legal liability and potentially an insurance liability that comes from the data that you're collecting and the human information that you pass back. I mean, so is this gentleman's question relevant to what you dealt with?
Well, I mean, maybe I'm a little, this is my opinion, not Volvo's, but maybe a little crotchety, but we get sued every day. It's no different than how it was before autonomous vehicle. Just by building a vehicle, we have there's an accident, many times we're getting pulled in one way or the other. Yeah, it doesn't happen very often, hopefully. But I mean, that's it's just the nature of the business. If you make vehicles and some things are going to happen. They're big pieces of steel going down the road, and things are going to happen unplanned, hopefully, and hopefully not caused. But that's that's just the nature of the beast of being in this industry, and in this country, you don't even need a good reason to sue, right? Sometimes. So it's just going to be part of the landscape that we're going to we address it through being very protective with our data. We have a telematics service agreement that we make sure our customers understand what we do with our data and what we don't, and how long we keep it and what we use it for. So we just want to be very transparent with what the data that we do have and how we're using it.
And I'm sure your customers all read the license data in detail, like we all do before we hit accept.
Click the box, yeah.
Yeah, right. Christopher, I see you're chomping at the bit.
I just want to maybe a bit of a clarification from my point of view. When we're talking about a self-driving vehicle, the data that vehicle's using will never leave that data to make those decisions, because we're asking an AI model to make decisions at the speed of a human mind, and the current AI models are equivalent to a 2-year-old child, that's why it's going to take a little bit longer. So none of that data will leave the car that's making that decision. So from an insurance standpoint, right, I mean, we're using that data for different reasons, not to drive that car. So from an insurance standpoint, 2 autonomous vehicles in 20 years have an accident. They're not supposed to. That's why we're eliminating drivers, right? But 2 autonomous vehicles have an accident. The 2 lawyers square up. What are they going to analyze? The AI model. Who's better has the AI model, company A or company B? I don't think it has anything to do with the data because they're collecting it real time. It's whose model reacted the best. And if you can prove a flaw in the model, Mr. Data Scientist, did you have all the budget, all the time, and all the resources that you needed in order to develop this model? you know? And the typical engineer is going to say, well, no, of course not, you know, because you're never done. So I think that's where it'll focus, not on the data, because in that environment, that data never leaves the vehicle.
So the only person who didn't get a chance to, just to wrap up our panel, because we're already 2 minutes over, I'm sure some of us will stick around to take more questions. But Katie, you want to have the last word?
Yes, I wanted to put a different technology spin to it. And then when it comes to that type of analysis, we're really saying that it can be solved by analytics, by data analytics, because you can tell if the data is corrupt or not. You can tell if there are missing information in there or not. You can tell if there has been a security breach or not, because the data is telling you if they have to follow a certain pattern or not. So that's something that at least you can answer this data is reliable, I can rely on that, or this model is reliable, it has enough confidence level to show that it can answer a good question, it's a good AI model or not. So you can do, you know, all kinds of model scoring, gradient boosting, all of that to see which model is better. But, you know, we can solve a problem with analytics.
With that, we're a mere 3 minutes over. Sorry about that. Thanks very much for attending. I hope you enjoyed the sessions. And what? Yes, I'm sorry. Tom, where is Tom? Tom Snyder, yeah. Between the two of us.
Yeah, I'll just say a quick thank you in the best back, Richard. Just thanks again to our friends at SAS, thanks to IIC. You in the audience, you're what's driving this market forward, so keep participating. Thanks for coming out. It was our pleasure to help.
Thank you very much. This is a partnership that worked incredibly well, by the way. Both staffs really enjoyed working with each other. And I can tell you that we very much enjoyed working with RIoT. And I hope you learned something. I did. And if you'd like to keep track of what's going on, keep a look on RIoT's website and keep a look on Industrial Internet Consortium's website, and we'll be happy to keep giving you information. We both publish all the information that we develop freely, so now's a good time to keep track of what's going on. Thank you very much.